Have you ever wondered how our world came to be? How did humans evolve from ancient ancestors? Why do stars shine in the night sky? To understand these mysteries, we need both history and science. History tells us the story of humanity, our triumphs and failures, our cultures and conflicts. It shows us how the past shapes our present. Science, on the other hand, seeks to explain the natural world through observation, experimentation, and the formulation of laws. It reveals the workings of the universe, from the smallest atom to the largest galaxy. Just as a detective needs clues to solve a case, we need history and science to understand who we are and where we come from. Imagine trying to understand a complex machine without knowing its blueprints or its history of use. You might figure out some parts, but you wouldn't grasp the whole picture. Similarly, history and science provide the context and tools we need to make sense of the world around us. By studying history, we learn about the decisions, inventions, and beliefs that have shaped human civilization. We see how societies have risen and fallen, how ideas have spread, and how conflicts have arisen and been resolved. This knowledge helps us understand current events and make informed decisions about the future. Science complements this historical perspective by providing us with a framework for understanding the physical and biological laws that govern our universe. Together, history and science illuminate the tapestry of our existence. They are not separate disciplines, but rather interwoven threads that create a richer, more nuanced understanding of our place in the cosmos.
The world we live in today is a product of countless historical events. From the rise and fall of empires to the development of new technologies, each event has left its mark on our societies, cultures, and even our genes.
Consider the impact of the printing press, invented in the 15th century. This single invention revolutionized communication, making knowledge more accessible and accelerating the spread of ideas. It paved the way for the Renaissance, the scientific revolution, and ultimately the modern world we know today.
Similarly, the discovery of agriculture over 10,000 years ago transformed human societies. No longer nomadic hunter-gatherers, humans could settle in one place and cultivate crops. This led to larger populations, the development of villages and cities, and the emergence of complex social structures.
The surplus of food and resources also allowed for specialization of labor, leading to the development of crafts, arts, and eventually the technologies we rely on today.
The echoes of the past are not always positive. Wars, famines, and diseases have also left their mark on human history. The Black Death, a devastating pandemic in the 14th century, wiped out a third of Europe's population and had profound social, economic, and cultural consequences.
Understanding such events, however tragic, helps us learn from the past and prepare for future challenges. By studying history, we can trace the threads of cause and effect that have shaped our world. We can learn from the mistakes of previous generations and build upon their successes.
Most importantly, we can gain a deeper appreciation for the complexities of human civilization and the interconnectedness of our shared past.
Throughout history, brilliant minds have pushed the boundaries of human knowledge, making groundbreaking discoveries that have transformed our understanding of the world. These individuals, driven by curiosity and a thirst for knowledge, have left an enduring legacy on science and humanity.
One such pioneer was Nicholas Copernicus, a Polish astronomer who challenged the long-held belief that the Earth was the center of the universe. In the 16th century, he proposed a heliocentric model, placing the Sun at the center of our solar system. This revolutionary idea sparked a scientific revolution, paving the way for future astronomers like Galileo Galilei and Johannes Kepler to make further discoveries about the cosmos.
In the realm of biology, Charles Darwin's theory of evolution by natural selection revolutionized our understanding of life on Earth. His meticulous observations and groundbreaking work, published in 1859, provided a framework for understanding the diversity of life and the interconnectedness of all living things. Darwin's ideas challenged prevailing beliefs about the origin of species and continue to shape our understanding of biology and genetics today.
These pioneers of progress were not always celebrated in their time. Copernicus's heliocentric model was met with resistance from the Church, which held on to the geocentric view. Darwin's theory of evolution also faced opposition from those who clung to traditional beliefs about creation. However, the power of their ideas, supported by evidence and observation, eventually prevailed.
Their stories remind us that progress in science and understanding often requires challenging established norms and embracing new ways of thinking. Scientific discoveries have not only expanded our understanding of the vast universe, but also revealed the intricate complexities of the microscopic world. The invention of the telescope in the 17th century allowed astronomers like Galileo to observe the heavens in unprecedented detail. Galileo's observations of the moon's craters, Jupiter's moons, and the phases of Venus provided evidence to support Copernicus's heliocentric model and forever changed our view of our place in the cosmos.
Centuries later, the invention of the microscope opened up a whole new world, invisible to the naked eye. Scientists could now peer into the building blocks of life, observing cells, bacteria, and other microorganisms for the first time. This led to groundbreaking discoveries in biology and medicine, paving the way for the development of vaccines, antibiotics, and other life-saving treatments.
The development of increasingly powerful telescopes and microscopes continues to push the boundaries of human knowledge. Today, astronomers use space-based telescopes to peer billions of years into the past, observing the formation of the first galaxies.
Biologists use electron microscopes to study the intricate structures within cells, unraveling the mysteries of DNA and the molecular machinery of life. These tools of discovery, from the telescope to the microscope, have not only expanded our understanding of the universe but also highlighted the interconnectedness of all things, from the vastness of space to the intricacies of the microcosm.